from the OpenBCI side today, you've got, my name's Joe Artuso. I'm the Chief Commercial Officer here. Been working with OpenBCI a long time. You'll both, known Connor, CEO for a while over the years. It's been great to see kind of the community of users around the world grow, and what's been done with OpenBCI hardware has been really inspiring, and it's allowed us to create this Galea product that we're working on. Joining me today is Eva Esteban and Musa Mahmood. You guys want to maybe pop off mute and just say hello?
Hey, everybody.
Hi, everyone. Thank you for coming.
So we had a couple extra things planned today, but unfortunately, some team members got sick who would be the ones to walk you through it and show it off. So we'll be postponing some of the face classification work until a future date. We've still got some great stuff for any Unity developers in the audience. We'll be excited about what we're working on today. And also it just gives more time for Q&A. I know that there's always a lot of questions about Galea and about the combination of physiological sensors and virtual reality, and what we see is really the future of computing, which is why we're working on this. So before handing it over to Eva and Musa, quick introduction of what we are working on for those who are maybe brand new. Galea is a combination of 6 different types of physiological sensor networks and VR headset. We are currently taking pre-orders for the beta run of devices that will be, maybe hold up the device, guys, while I just talk through it so they can see what the alpha units look like. So what we've been working on today, a little higher. Yeah. So what we've been working on today, this is one of our alpha units, which is attached to the Valve Index. They've been excellent partners with us. The beta devices will be shipped, integrated with the Vario Era. You can see more information about the Galea beta units and the specs for Galea at galea.co, which I just dropped into the chat. It's got sensors for 8 active EEG sensors. It's got face pad sensors for muscle activity, skin conductivity, EOG, a PPG sensor for heart rate, and also the Vario Aero comes with integrated image-based eye tracking. That's pretty high quality. We're excited about that. So without further ado, Eva, Musa, maybe you guys can take over and talk a little bit about what you'll be showing first.
Thank you, Joe, for the introduction and the walkthrough. So like Joe mentioned, we're going to be showing some demonstrations of how to use Galea with Unity. Specifically, we're going to walk you through a tutorial of how to get started with a Unity project from scratch and add Galea data streaming into it. We made a custom SDK for this, so the process is pretty simple. And then afterwards, I'm going to show you an example of a short application that we developed, which uses a particle system, and it has some of the variables that make the particle system change mapped to values from the Galea device, some of the brainwave values. And finally, we're going to show you an example of how to add event markers to your experiments. So we've developed an application that allows you to add automatic and also manual markers to the data that is getting streamed from your device in case you need to indicate important events or moments that happen while you're running scientific experiments with it. So the first thing that I'm going to do is share my screen, and we can jump right into the Unity tutorial. Joe, let me know when you see my screen.
Yeah, I will. Not yet. And yep, it's popping up now. Cool. So I see your Unity Hub 3.2.0.
Yes.
I also see some background artwork from Greg Dunn, who's extremely talented and makes great brain art etching, in case you haven't seen that before.
Yeah, we have a couple of these at the office as well. They're very nice. Okay, so right now I have Unity Hub open, and we already connected Galea to our computer. For this, let me drag the hotspot menu. For this, we're creating a hotspot with the computer and then turning the device on, and it automatically connects to it. We've already walked you through this in our previous 2 webinars, so I'm not going to dive into it. And once the device is connected, the first thing you need to do is open Unity Hub and click on New Project. For this example, I'm gonna use the 3D high definition rendering pipeline. I'm just gonna select it and then give it a name. For example, webinar. And then click on Create Project.
So Ava, what you're doing now is basically just showing how to go from nothing to a new Unity project that has Galea connected and data from Galea flowing into it.
Yes. So I'm starting a new Unity project from scratch. And actually, if you're familiar with Unity rendering pipelines, there's a few you can use. So you can use the legacy pipeline or 3D pipeline. You can use the universal rendering pipeline, and you can use the high definition rendering pipeline. For this example, I'm selecting the high definition one, just because we've added a few assets to the project that I'm gonna show you later that belong to that pipeline. But the OpenBCI toolkit that I'm gonna import is independent from this, so you could use it with any of the pipelines. It's gonna take a little bit to load.
And I just shared a couple links to a YouTube playlist, OpenBCI YouTube channel that has previous webinars. There's good, if you kind of watch the first 10-15 minutes of those, you can get a good sort of walkthrough of the data types that Galea collects. There's one shorter video actually that has its own file that goes through. It's Ava and Connor going through all the data that Galea collects and each of the the features of the OpenBCI graphical user interface that'll be shipped along with the beta units. What's also included with the beta runner devices will be the Unity Galea SDK, which based on BrainFlow makes it really easy to get data from Galea into Python, C, C++, almost any programming language. You can use it with MATLAB. You can also get data into Unity using the Galea SDK. What we'll be including with that is a bunch of sample projects that kind of show, here's some sample code that goes along with this, so you can understand, how do I use the muscle sensor data to push buttons in Unity? How do I use the brainwave data to alter the audio or the video in a scene? So also, it'll include kind of, Ava's going to walk you through what the package sort of looks like to install some of those SDK features for the first time.
I think it's gonna be loaded soon. We still need to wait a little bit. Usually, the first time you start a project with Unity, it takes a while to load all the folders.
And if anyone does, if you have questions, you can start dropping them into the Q&A so other people can upvote them. We'll have a little bit more time for Q&A this session. So if there's anything that you do want to know about Galea in general, yes, start dropping those questions in and we can queue them up for later.
Okay, so the project loaded and you'll probably get this pop-up. You can just close it. And now we see an empty Unity project. So the first thing that we need to do is import the OpenBCI SDK that we've developed into it. For that, I'm gonna go on Window and then Package Manager. And then on the plus sign, I can import a package from Tarball. So I already downloaded the package into my folder structure and I can click open. Again, it's gonna take a little bit to load the first time. So if you wanna address any questions, Joe.
We have one question, which was, can Galea be used with other headsets? For example, the Oculus Quest? Not immediately, but we are designing the system so that the Galea sensor suite is kind of separate. It's a separate electrical system. It's battery powered, it's wireless. It's separate from the HMD itself. the devices we'll be shipping will be kind of fully integrated into a Vario Aero unit. But down the line, we want to be bringing this to AR and VR headsets, and we're designing it so that it would be easy to adapt, the current design for additional support of headsets.
You can see right now that I'm getting a few pop-ups. You can just say yes. They're just making sure that you made a backup and anything that you need. And then afterwards, the project will close and open again. It's still importing things. And now you see the same pop-up that I closed at the beginning, but this time we're gonna select the high definition rendering pipeline plus VR option. And basically what's happening is that Unity needs to make sure that you have all the links and all the files that you need to run this. And it's pretty smart. So it tells you what is wrong and what you are missing. So it makes it easy to add all of that if you just click on fix all. That's what I'm gonna do right now. Okay, so once it's finished fixing everything, you will see that there's no longer red icons telling me that something's wrong. So the project is ready to go. I can close the pop-up. I can close this too. So basically what I did is I imported the OpenBCI SDK into my project, and I can now see it under packages. So if you go to packages on the bottom left of my screen, where my mouse is, and you select OpenBCI SDK, we've added a few prefabs into this SDK. One of them is the Galea prefab, which I'm gonna drag and drop onto my scene. This prefab, for those of you that attended the previous webinar, is probably familiar because we did show it a little bit. What it does is it allows you to connect to the device, and it also allows you to change some of the parameters, such as, for example, the filters. So on the Galea board script where my mouse is, you can see that right now I'm using a 50 and 60 Hertz notch filter. I have the option to select either 50 or 60. In this case, I have both. Depending on whether you're in Europe or in the US, you want to use one or the other. And I have a few other options like the data acquisition %, for example. It also gives me the option to visualize some of the data that's coming in from the device live. So what I'm gonna do is feeding the IP address for the specific device that we have in the office right now, and then we will be able to see the data streaming. Let me check. 88. Okay, so the IP address ends in 88. Oh. And that, can you hold the, sure. Actually, you might want to put it on so we can see real data. Yep. So Musa's gonna put on the headset, and then we'll be able to see some of his data streaming into the Unity project.
Check the right here.
You have it?
Yeah.
Nice. So you guys can see him on camera with the device on, and I'm gonna click play. And if you look on the right side of my screen, there are some drop downs that I'm opening right now. Delta, theta, alpha, these are power bands for the brain activity from Musa's head. And as you can see, the number is changing in real time. So it's giving me an average value for each power band and a standard deviation value. If I scroll down a little bit, I can also see the mindfulness value and the restfulness value. These come from machine learning models that we've trained to be able to detect these states. So that's a demonstration of how the Galea data is getting piped into Unity. Now I'm going to show you how to add controllers and a VR camera onto the scene so that Musa can actually see the game inside his headset. For that, I'm going to pause it and go down to the OpenBCI SDK package again. Over here, you can see there's an XR origin. So I'm going to drag this prefab onto the scene. And then if we open it up, you can see that there's camera, right controller, left controller. So I need to delete the main camera that was in the scene by default. Otherwise, Unity will give me an error because it won't know which one to use. I'm going to delete it. Let me turn on the controller. So I have one controller paired. Musa's holding it right now, and I'm going to run the game again. Oh, actually, I think I needed to load the game manager as well. Sorry for that. So I loaded the XR origin, and also you need to drag the game manager. And then if we go back to the game. Can you see it inside VR?
No, I can't. Let's go.
Let me check. Okay, okay. So right now, okay, I dragged all the elements into the scene, but I need to tell Unity that we want to use the OpenXR plugin. I did this before the webinar. I thought it was saved, but we have to do it every time we do a new project. So if you go to edit, if you go to edit and then what's the pop-up? Project settings, and then scroll down all the way to XR plugin management, you need to select whether you want to use Oculus, OpenXR, or Mock HMD. In this case, I'm using OpenXR because that's the one that we used to develop the XR rig that I dragged into the scene. So I just clicked on it to select it. Okay. And then inside OpenXR, we need to tell Unity which controller profile we want to use. In our case, Musa has a valve index controller. So I'm gonna select valve index controller profile and add it. And I think that should be it. If I close this. Let's see. Okay, so right now, if you guys can see my Steam VR little window on the bottom right, now Musa can see the game into the headset, whereas previously it was only running on the computer because I hadn't specified that I needed to use OpenXR. So make sure that you do that step every time that you start any project. And can you put your hand up so we see? So you can see the controller appears as a hand. And if I go to the Galea prefab on the right, I'm just gonna move that window out of the way. On the right, I'm able to see the data that's coming in real time from his head. So basically what we have right now is a Unity project that you can load into the HMD, that you can look around in and see in VR. And at the same time, we have Galea data coming into the project in real time. This is the basics that you need to get started with Galea development. And then on top of this, you can develop your games and start linking the data to objects that you add in your scene. So I think that's basically the first part of the webinar, which is the tutorial. Now what I'm going to show you is one of the examples of things that you can do once you have data streaming into Unity. So I'm going to stop the game. And the example that we developed is called band power. Let me find it in my folder. Structure. Okay, so I have a folder here with the material that we use for our demos. And on the bottom, we have a Unity package file called band power sphere. I'm gonna double click on it and that should import it into Unity. Import. Okay, so it imported correctly. And if you go to assets and then prefabs, we can see that it's there. What I'm gonna do is drag it onto my scene. And I'm going to quickly turn the sky and the background black so that you guys can see it better. So let me just, I'm gonna switch from physically based to gradient, for example, and then make it black. Okay, I think that should be enough for you to see. So what you can see right now on the screen is a particle system that we made. And what we did with it is map the average value of some of the different power bands that I was talking about earlier, like delta, theta, alpha, beta, and gamma, to different variables in the system. I think the easiest one to demonstrate is alpha. So I'm gonna untick the other 4, and we are going to leave alpha mapped to the basically the turbulence of the system, so that when the user is producing high alpha, you'll see the system starts to expand and move faster. And when their alpha value is low, it gets smaller. Let's run the game. Okay. So on the screen right now, you can see what Musa is seeing inside VR. Can you see it?
Yes.
Okay, nice.
Just let me know if you want me to close my eyes.
So yeah, Ava, this is just like a, one of the particle effects that we've used, and we've hooked it up now to the EEG data that's coming from Galea, right?
Yeah, it's basically to hook to the active electrode data from the back of his head and the midline. And we're calculating different power band values, and the system is changing and adapting to the values that Moose is producing. If you want to close your eyes and make some alpha, we can try. I see right now that actually all the power bands are mapped. I think it's because the script probably has them linked, and it might be overwriting what I changed earlier. But you can see how the system is changing. And at the same time, you can see the values on the right.
But yeah, this is just another one, another sort of small example of how you can start using the physiological data that Galea can collect and connecting it to kind of visual audio gameplay elements within a VR environment. We're really excited to see what kind of the first batch of beta customers will be producing with this. We've put together, some kind of meditation room demos and other things in-house, but really we're like with our first round of products, we're excited to see, the unexpected things that come back that people are able to generate. There was a question actually in the chat that I think would be good to touch on. Asaf Harel asked, hey Asaf, is the raw data also available through Unity?
Yes, the raw data is also available because in order to connect Galea to Unity, we're using a library called BrainFlow. And the first thing that the library gives you is the raw data. In this case, we haven't mapped it to our example, but it's definitely available. And you could show it on the screen just like I'm showing the power band values.
Yeah. And then Galea also, you can save any recording session of Galea to a CSV or PDF or other file format that has all the channels of data with the timestamps and marker columns as well, which I think we'll touch on next, unless there's anything else here, Ava.
Yeah, actually, I was going to say the recording file name saving option is something that we're going to use for the next demonstration. So you'll be able to see how the data gets saved, and then we're going to actually plot it with Python. So, okay, I think that concludes the first part, which is a tutorial on how to get started with Galea and Unity. Now, what I'm going to do is show you how to add markers to your experiment or to your application.
So this was something that came up in our last webinar, was a question, and it's come up with some of the early partners that we're working with the devices that we've built so far. Everyone wants to be able to, anyone who's done experiments using this type of data knows how tedious it can be to have to manually mark relevant points in the data stream. So we've been building features to kind of automate some of that based on most common interaction types that we could think of, and we're adding to it as well. And that's what Ava's going to run through now.
Yeah. So there's different ways that people were requesting to add markers. Like it can be manually, automatically, or by interacting with the VR scene. I'm going to show you an example of each of those. The first thing that I need to do is go to Window again and the Package Manager, just like we did earlier. And here we can see the OpenBCI SDK that I imported earlier under Packages-OpenBCI. If I expand it, there's a section called Samples. And if I open it, you can see two, the headset adjustment and the event markers. The headset adjustment sample is actually the work that we were showing in the last webinar, if any of you watched it. And the event markers is a new one that I'm going to import. And we need to wait for a little bit. Okay, so I imported it into my project. It will appear under Assets, Samples, then OpenBCI SDK, the version, event markers, and scenes. There should be a marker scene here that I'm going to open. And when you get prompted to import the TextMesh Pro, just say yes, because we need some of those elements. We don't need the examples and the extras, so I'm not going to import that one. And let's see. I can see, I think some of the elements from TextMesh Pro didn't get imported, so I'm gonna do it again. This can happen the first time that you load it. If this happens, you can delete the folder and just repeat the process one time. Samples. So again, we go to Window, Package Manager, OpenBCI SDK, Event Markers. Okay, now you can see the text actually popped up. And so I'm gonna run, well, actually the first thing I need to do, because this is a new scene, I need to give it the IP address for Galea again. So I can open my hotspot menu, see that it's ending in 88 and update that. Same thing we did previously. And then it should be ready to run. So let's run it. How is it looking?
Looks good.
Okay. So Musa right now is seeing what you guys see on the screen. And there's basically 4 different sections for markers. Let's go through them one by one. Can you guys read what's in the screen? It might be too small for Zoom.
It's a little, I think the resolution on Zoom means I can read the orange text, but not the white text on those boxes.
Okay, I can read it out. Basically,
Yeah, it's the Zoom video quality kind of cuts it down.
Yeah.
Just read it.
The first marker option that we have is called the toggle marker. The way this one works is that by enabling and disabling the script over here on the right of the screen, it'll insert a marker, which will be either 1 if you toggle it on or -1 if you toggle it off, into the data that's getting streamed from Galea. And I just realized we never gave it a recording file name, so I'm going to stop it before we insert the markers and give it a name so that I can recognize the file afterwards. So for example, webinar. Webinar test. Oh. You can set any name that you want. I'm going to say webinar test and we're going to run it again. So that after this, I can search for the file on my computer in the right folder and we can see the markers and I can show you guys a plot of what they look like. So like I was saying, the first one is the toggle marker. I've opened up the console as well so that you can see every time I add a marker, it prints it out for the user to know. So if I disable the script, I can see that it says adding a marker with value -1. If I enable it, it says adding marker with value 1. So this one is more for the person that is on the computer running the application while the subject is doing something. So if I give Musa instructions and I want to mark that on the data, I can just use this. It's very easy. The second marker option, can you look a little bit to the right? Yeah. The second one is called a collision marker. This one is a marker that gives the opportunity to Musa to add stuff onto the data. So inside the scene, he can touch the red cube that you can see. And I'm just going to quickly open it here so you can see. And if you look on the right of my screen, you can see that it says the collision enter value is 4 and the collision exit value is -4. What it's basically doing is that when Musa is touching the block inside VR, it'll add a marker, the marker number 4 onto that data point, And if he stops touching the cube, it'll add a -4. So that's a way for the subject to, for example, be able to press a button inside the experiment. Like say you want them to recognize, I don't know, a picture that you're showing them or something, and you want them to press something when they see it. Instead of doing it in the real world, they can interact with it directly inside VR. Nice. Let's move on to the eye gaze marker. So the eye gaze marker is a functionality that we have implemented in software, where when the subject looks at the cube, it adds a 3 as a marker, and when they stop looking, it's a -3. But right now, because we're using an alpha unit, this specific unit doesn't have eye tracking, so I can't demonstrate it, but we'll be able to show it to you guys in the next webinar once we have the Varjo headset attached. And finally, there's the input action marker. This option adds a value of 2, and it gets triggered when either I press the keyboard letter M, which I'm gonna do right now. I'm pressing M, and you can see on the console it says adding marker with value 2, or when Musa presses B on the controller. So that's something that both the person and the computer and the subject wearing the device can use. So you can see he's pressing it, and it's notifying us that the markers are getting added to the data. Nice. Okay, so that's the 4 marker options that we have right now. And what we're gonna do next is have a look at the data that was saved and plot some of the markers that we just put into it with the timestamp that they happened at. So I'm gonna stop the game. And I think you can remove the headset actually, or you don't need it anymore. If you want to find where the data is stored, you can check your Unity Hub for where you created your project. And then go to that folder. In my case, it's webinar project. And I can see here the file that was created. It's a CSV file, and it's called webinar test, which is the name that I gave it earlier. When you open it up, it's basically the raw data coming from the device. So what they were asking earlier, Joe, and you have all the different columns which each correspond to one of the channels. We can get into that later in the Q&A if you want to learn more about it. For now, what I'm going to do is take a script that we made and run it on this data. Let me see. I think I need to copy it into the folder.
One question that's popping up: what is the frame rate of the VR system that we've been running on today? Do you guys remember what setting we're using on the index? Is it 90, 60? I know it has like variable.
I'll put it there. I can't remember off the top of my head right now, but we can check afterwards.
Cool. This unit is the valve index, which lets you, I think they do like 60, 90, up to like 144 hertz. You can toggle between them. The Galea system at the moment has a sampling rate of 250 hertz, although we're pushing that higher in sort of future releases of upgrades to the firmware that we're working on now.
Oh, you moved the data file here. Okay.
Yeah, you can just run from here.
So here is the plot that I was talking about. This plot shows you what the time was in seconds at which we added different markers for the data. So you can see red is the toggle marker, which was value either 1 or -1. You can see that on the left axis. We started the demonstration with that one, so you can see we did a few at the beginning. Then came the collision marker. That one is 4 or -4, and you can see the ones that Musa was inserting into the data. And then we have the input action marker, which is the blue one. That one is only 2. So that's the one that I was inserting when I was pressing the keyboard, or Musa was inserting when he was pressing B on the controller. And the eye gaze marker we haven't used. So this is just an example for you to see how you can indicate when certain things are happening in your experiment.
That's awesome. I think it's going to save people a lot of time. We need to send this to some of the labs that are already working with the systems we sent out last week. Because they're asking how to integrate markers into VR experiments that they've already designed. And this was our effort to try and make it a lot easier to both add those different events into the data file that is generated from Galea and visualize it quickly.
Yeah, of course, this plot is just time and marker, but if you know which data you want to be looking at that specific moment, you can just plot one on top of the other, and then the marker will tell you exactly when the action happened.
Cool. So I think with that, actually, do you guys still have Galea connected?
Yes.
Yeah.
Are you able to just there's one question. Are you able to pull up the GUI quickly just to show some of the graphs, the visualization elements that have been built? You don't need to do anything with it, but Emily Coffey asked, can you visualize the physiological signals in real time? The answer is yes. You can do that with the software that we've provided for visualization, the graphical user interface, the GUI. You can also visualize it inside of Unity. Some of the other stuff, Musa, you've created your own graphs for some of the metrics that you've been building and classification systems you've been working on. So both are possible. How real time is real time? That's a great question. We do track actually, Ava, maybe you can, do you have a number or any commentary on kind of how real time, or what's the delay in milliseconds from kind of, recording it through Galea?
Yeah, I can chime in on that. I'm actually just gonna connect the system again.
And then, go ahead, Ava.
We've been running a few tests to measure the delay, and right now it sits at around, like, worst case scenario is around 7 milliseconds, which is within the limits of what the people that we've been speaking to at labs need to use. And the way that we're measuring that is by calculating the round trip time of a few data samples. We send them from the device to the computer and then back to the device. And we measure how long that transaction takes, and then average across a few data samples and half it to get the delay, the one-way delay. And that's around 7 milliseconds from the test that we've been running.
And when because you can calculate and track that round trip time across different samples, you can account for it. When you're doing an experiment. Yeah,
basically every time that you run the GUI with the data files, there's another file that gets saved, and that file has the values for the round trip time for your specific session. So you'll be able to use these values in order to pinpoint exactly when things were happening. Let me start the GUI. Okay, another thing I wanted to demonstrate, actually, if you just saw that, is that I did not put the IP address into the GUI. This is a new feature that we've added. So previously we had to go into this menu and copy and paste the IP address in the GUI initialization menu for the GUI to be able to tell which one, where which Galea you want to connect to. And now we've added a feature that automatically lets the GUI find the IP address of the device and connect to it. So you don't need to do the copy pasting anymore, which is nice. And here is the data coming in from the device. Do you want to wear it again?
Yeah, sure. It might also be worth showing the different widgets, like the networking widget that we use to interact
Sure.
with other demos and all the different filtering features. People want to see that.
Is there any specific data, like widgets, that you want us to show, Joe, or just a general walk?
I think you can, show the EMG. I actually think what we have up there is good. This was just to give an idea of like, here's some of the visualization capabilities that we've covered previously. You can talk about the networking widget for a second too. A couple other questions that are out there. I'm gonna say that one. Actually, one question, for the frequency bands, what numbers are those expressed in? Average. This was actually from earlier when we were in Unity, but I think, there was one question about the overall filtering that we're applying, and maybe, you can show that some of that in the GUI currently. What filters are available? What filters are available? What filters are easily, added to the data that Galea generates? And then this question may be a little bit more for some of the work that Moose has been doing, but like how do you account for artifacts in the data currently?
Okay, those are both very good questions. I can chime in on the filters, and then probably you can speak a little bit about the artifacts.
Yeah.
So right now you can see on the screen the data is coming in from the different channels. I can walk you through them in a sec, but here on the top, there's a filters menu. And if I open it, it tells you which filters are getting applied right now. So right now we have a notch filter for 50 plus 60 Hertz. This is to remove the noise that comes in from mains. 50 or 60 changes whether you're in the US or in Europe. We just apply both because it makes it easier. That way we know that wherever the user is, the moment they turn the GUI on, it's gonna be removing that noise. And then we're also applying a bandpass filter from 5 to 50, because that's the range where you get the most important information in, and we're really not interested in outside of it. But if you are, you could choose any filter that you want. So the fields for start and stop are editable. I can just say like 2 here, and I don't know, like 70, for example. And I can also choose which type of bandpass filter. We offer a few options. There's Butterworth, Bessel, and Chebyshev. I don't know if I pronounced that correctly, but hopefully you can see them on the Zoom. And yeah, you can just select any values that you want and then click save. Oh, actually, I just saved it. I'm just saving it into settings. That's fine. Oh.
It's just excellent.
Oh. Oh, I have the money open. Okay, here. So I saved it, and then I opened it up again to make sure that they're the values that I put. You can also select which channel you want to apply it to. So it doesn't have to be the same filter for all the channels. We break them all down, and you can specify the range that you want for each of them. Try putting it back to the previous. I think it gets saved when I close. Let me check.
One other quick question we can answer that's popped up. Does the signal travel over Bluetooth? If so, do several VR sets go into conflict if they're used in proximity? We're using Wi-Fi. We're using a Wi-Fi network that Galea creates. So that part is wireless. We have the ability to use multiple systems in the same room. We haven't tested more than 4 or 5 at a time, but you're able to kind of spin up independent connections for each device and have them working simultaneously. We're not using Bluetooth for this device.
Yep. Just to clarify, earlier when I clicked on save, what it does is that it allows you to save your specific filter configuration as well. If there's a configuration that you want to use for your experiments, but you don't want to change it every single time, you can also save specific settings that you use often. And then maybe Musa, you can speak on the artifacts question.
Yeah, you want to take off the headset?
Can you do it with the headset
Yeah,
on?
sure. So yeah, the main cause of artifacts right now is motion, and one of the ways we're going to tackle that is by adding a IMU, and inertial measurement unit that measures acceleration, and it has also the gyroscope on board, and sampling that at a similar rate as we sample our bipotential features, we can subtract motion noise out of the signal, and that will help us get better translation on both our PPG side and on our bipotentials. So that's one way we can deal with it. And obviously the digital filters and hardware are also hard at work removing noise. Yeah, so
Great.
We're in the process of doing classification right now, and we have a few things set up already, but yeah, we're not demonstrating that at this time. Maybe next time we'll demonstrate it.
Great. One question came in about the sampling rate. So currently the sampling rate, the system we're showing right now is 250 hertz. Ava, what is are you plugged in on the status of, kind of pushing that forward?
Yeah, so right now it's like Joe said, 250 hertz. It's actually 250 hertz for all the EXG channels, so like EMG, EOG, EEG, and the ADA. I think we're sampling PPG at like 50 hertz because we don't need, we don't need 250 for that. And then we have made it work successfully with 500 hertz, and we're bumping it up to 1,000 hertz. Currently in the process of running tests with that. So probably in future sessions, we will be using higher sampling rate. Another thing I want to mention is that we're going to add the option for you to choose sampling rates for different sensors. So say you wanted to sample the EDA or the PPG at a specific rate and the other channels at like 500. We want to add the option for the user to be able to select this.
Cool, thank you. I think that was for Ziga's question.
And I guess we can show a little bit of the widgets. Oh, you have the bumpers.
Another question out there was, when will a cheaper, more mass-produced device be released? As soon as possible. As soon as we can, afford to make one, and also really as soon as there's a mass-produced consumer use case for them. We're learning a lot in the process from our beta units, and we'll be taking that into account as we design future hardware runs. And even kind of related to Samuel Hazovsky's question about what Valve said they're doing with the research with Galea. I think most of the application at the moment is for companies that are interested in doing research with these signals, so that they are going to be using that research, using that knowledge over the next couple of years to develop more consumer-focused applications of them. So give you some idea, the overall goal will be to modularize, make it smaller, make it adaptable to different headsets, but it may take some time for the market to catch up for that.
Musa's just readjusting the headset a little bit. most of the channels, the active elect, well, I'll wait until you stop moving it.
Oh, okay. I didn't have it correct.
Very nice. So here is some of the data. Most of the channels are looking okay. The active electrodes 11 through 16 look really good. 10 is a little bit noisy. It might be floating on your head. Yeah, I think it's, you need to adjust the arm a little bit.
Another question, you know,
Nice.
talking about the difference between kind of passive and active BCI use cases. You know, passive BCI certainly kind of like user experience testing, you know, quantifying qualitative experiences. Active BCI use cases, I mean, we're seeing, I think the combination of the EMG data from the face with the eye tracking, there's a bit of a challenge. Right now, you kind of have to rely on gaze like dwell time for selection with eye tracking, and there's plenty of muscles, you know, around the area where AR and VR headsets interact with that you could, you know, toggle and use to, you know, select buttons. We have demos from previous examples where, you know, we've mapped like left, right, up, down to different facial expression movements, but I think it'll be kind of combining eye tracking with muscle movements more so than brain movements. We don't think the motor imagery side of things is going to produce a satisfying enough accuracy and speed, whereas eye and muscle movements, you know, would be where we see companies focusing more for active control with BCI.
Okay, so right now we can show you a few of the widgets, unless you want to answer more questions, Joe. If not, we can give a quick walkthrough.
There's just one question. I mean, we're almost at time actually. So there was one question about maybe showing some eye blinks and, you know, jaw grits and some alpha. Maybe you can use that to walk through.
Good segue. So right now, actually, most of the channels look okay. I turned off a couple channels because some of the hair was getting in the way, and we also don't really need them for to show what they were asking about. Channels, I'll just quickly explain, like channels 1, 2, 3, and 4 are EMG. Channels 5 and 6 are EOG, electrocoolography. Channels 7 and 8 are passive EEG. And then channels 9 through 16 are active EEG. You can see the location of the channels on the signal quality widget, which is on the top right of the screen. So each channel has a number, and in that widget, you can see where they're located on the head. To show blinks, for example, channels 7 and 8, which are the passive EEG located on the forehead, are really good. And if you look closely right now, I can tell that Musa is blinking more or less every second. Can you do like 5 blinks in a row? So if you look at where my mouse is, those are his blinks, and they're very clear. You can also see them propagate to other channels on the face interface, but 7 and 8 are the best ones to visualize them. Also, let's show, can you clench your jaw? That's a jaw clench. You can see it's spiking the data, and it also propagates throughout the headset because he's flexing basically all the muscles around his ears. And let's show, we could do left cheek versus right cheek. So there's a widget called the EMG widget. This one shows you the EMG data normalized from 0 to 1, and also a few parameters that you can tweak to say what the minimum and maximum values you want for you want to use for the normalization. And so, for example, if Musa smirks left and then right, then left and right, we can see in channel 1 and 2, which are the left cheek channel and the right cheek channel, that the bars get filled up to the top. So basically up to a value of 1. And this is one of the methods, or one of the data options that we've used to develop some of the demos if you came to the previous webinars. So that's some EMG for you. And if I wanted, for example, to use that EMG to control a game, like we've shown, I can open the networking widget and I can choose to stream this EMG data or basically any other widget data out of the GUI using one of the protocols that we offer. So Serial, LSL, UDP, and OSC. I can choose a protocol and choose a stream and then start a UDP socket. And the GUI will basically send the data out and I can catch it with another application.
All right, so we're coming to the end now. We'll do two more questions. One of them from Matthew. In addition to consumer use cases being developed, are there medical use cases being actively pursued? So good question. Galea will not be, immediately won't be a certified medical device. So that limits some of the applications, but there's still non-clinical research and work being done that will be done with Galea in the medical space. There's a lot of interest in, from companies that provide meditation or kind of VR wellness experiences and using Galea to quantify the effects of their interventions and other kind of digital therapeutic interventions, being able to track brain activity and other physiological data during those experiences is an area of focus from our early customers. There's also, just in the research space, using it to investigate depression, ADHD, and other ways of treating these common conditions. The types of data that we're collecting with Galea for a long time have been recognized as useful in studying those conditions. And now we're trying to put something into the world that makes it easy to collect as much as possible at once, while also working in a VR environment, which has been really useful for, as an experiment platform for lots of people, because you can control the setting and make it realistic.
And just a quick thing, right now I opened the band power and the FFT and we can do a quick alpha show. So if you close your eyes, Musa.
I don't know, Musa's not too good at this.
Okay.
Oh, there it is. There it is.
Other people in the office. Sorry, Musa. And so if you close your eyes, we did see a little peak earlier, and now you can see the alpha power band goes above the other power bands, and you can also see the peak when it pops up in the FFT graph at around 10 Hertz. So I can see some peaks for you, not sustained.
So this is what we've tied to the particle effect earlier, so that when the alpha band wave increased, the particle effect became more active. That was just one example of how this type of data can be used to make, augment a scene to be actually responsive to your brain activity in real time. Okay, and then last question from Vagram. When will we see the next leap in non-invasive BCIs? Months, years, or decades? What are the main stoppers? I think one of the main stoppers is really, it's always been making tools available that can be used by multiple developers, reproduced easily, not just kind of ad hoc systems that are one-off, which is a big request from our existing customer base that we're trying to meet with Galea, is give something that's sort of standardized around a certain combination of sensors. I think the advance is happening now. If you look at the number of companies working in the space, the amount of research being done with non-invasive BCI, it's just been accelerating every year that we've been a business. And really the last 5 years, we've seen interest and activity in the space that when we started, just wasn't there. So it's really exciting to be alive, right now during the neurotech revolution. And I think that's what we had prepared for today. Thank you, Ava. Thank you, Musa. And thanks everybody who's all of you who are still with us. We will be taking this recording, gonna process it and add a couple things, and then we're gonna put it up on YouTube. So most of you will probably get an email as a follow-up when that's ready. So just keep an eye on that. And then, if you have any questions for us about Galea, or you have recommendations for future content that you'd like to see in events like this, you can reach us actually, I'm just gonna drop the email in here. You can always, reach out to the team and yeah, let us know what you are interested in seeing next. All right.
Thank you everyone for coming. See you in the next one.
Thanks, everybody.